Good afternoon, ladies and gentlemen, and welcome to the MPMA PLASTECH Month 2021. Today's webinar is entitled Unlocking Greater Efficiency Through Manufacturing Execution Systems. Let me begin by running through the etiquette for today's webinar. So we are using a webinar platform on Zoom, and therefore all participants' mics have been muted and videos turned off to ensure no disruptions during the webinar and to the speakers. Participants may pose questions related to the presentations in the chat box during the webinar, and the speakers will only answer questions that are clearly written and based on the presentations. So kindly refrain from marketing your goods and services in the chat box, and also kindly refrain from posting comments or remarks to questions posted in the chat box. So leave these comments and questions for the moderator and speakers to answer. The chat box is only for queries related to the presentations, and MPMA reserves the right to remove participants that do not comply to these rules. So the MPMA PLASTECH Month 2021 is brought to you by MPMA with the generous support of our sponsors from the Malaysian plastics industry. And please allow me to take this time to thank the sponsors. Our platinum sponsor is Monitor ERP Systems. Gold sponsors PT Bobs Jakarta, Milliken Asia Private Limited, NGR Malaysia Sendirian Berhad, Petronas Chemicals Group Berhad, Reifenhauser Blown Flynn GmbH, Windmoller and Holscher Asia Pacific Company Limited. Silver sponsors, we have three: Arberg Sendirian Berhad, Not Mechanica SPA, and Syspro Software Malaysia Sendirian Berhad. Bronze sponsors, Autodesk Malaysia, Ben Mayers Specialties Malaysia Sendirian Berhad, Perush Private Limited, Husky Injection Molding Systems Malaysia Sendirian Berhad, Rickerman Malaysia Sendirian Berhad, Sigma Soft Sendirian Berhad, Torre Plastics Malaysia Sendirian Berhad. And other sponsors, we have one, which is Kryberg TPE Technology Malaysia Sendirian Berhad. Thank you once again, sponsors, for making the MPMA PLASTECH Month 2021 a reality. So, and we would like to appreciate our platinum sponsor at this time, Monitor ERP Systems, for their contribution towards the event. And we will now play their corporate video. Thank you, Monitor ERP Systems, and Mr. Daniel Hickmark, who is the Managing Director of Monitor ERP Systems. Daniel is a speaker today for your support towards the MPMA PLASTECH Month 2021. Thank you. We will move on now with the introduction of our moderator. He is none other than Mr. Travis Tan. Travis is the Managing Director of Prestige Dynamics Industries Sendirian Berhad and EcoFrame Sendirian Berhad. He is also the committee member of MPMA Northern Branch based in Penang and chairman of the MPMA PTTC Northern Branch. Mr. Travis, the virtual floor is yours.
Thank you, Sujata, for your kind introduction. Good afternoon, fellow MPMA members and guests. We have today with us 4 speakers to help us unlock greater efficiency through MES, which is also our topic for today's PLASTECH webinar. Let me quickly brief on the program. Our first speaker, Dr. Chua, will be covering on manufacturing execution systems and overall equipment efficiency. For our second speaker, Mr. Stephen Liu will be speaking on production scheduling for plastic injection molding factories. The next speaker, Mr. Daniel, will present on increasing performance and supply chain management. And last but not least, our final speaker, Mr. T, will guide us through optimizing the value and performance of machine and production through Lean. Allow me to introduce the speaker. Our first speaker, Dr. Chua Wen Xuan, is currently the head of Malaysia Smart Factory 4.0 under the Selangor Human Resource Development Center. He is an expert in control and automation system, fault detection and identification, and predictive maintenance strategies, which are widely used in industry for application. He is also appointed by the Malaysian Productivity Corporation in collaboration with the Machinery and Equipment Productivity Nexus as one of the mentors for the Productivity 1010 initiative to support the industries in their journey towards digital transformation. Our second speaker, Stephen Liu, is the account manager of Simation Malaysia. Simation was established in 1996 and specialized in developing systems for Industry 4.0, which includes overall equipment effectiveness automation system, manufacturing execution system, automated line control. Stephen was involved in the designs and development of MES and control application for computer integrated manufacturing for aerospace companies manufacturing plant. Our third speaker, Daniel Heckmark, is the Managing Director of Monitor ERP System. With more than a decade of regional experience, Daniel leads the development and expansion into new markets for Monitor in Southeast Asia. He spearheads business growth and strengthens Monitor's partnership with customers that believe in digital transformation strategy. He empowers more than 100 manufacturing companies in Southeast Asia through Swedish manufacturing best practices. Our final speaker, T. Ji Seng, is a trainer, coach, consultant of Eagle Vision Lean Academy. He was involved in lean supply chain industry for more than 30 years. He worked in senior management position in various multinational corporations in Malaysia and also overseas for a multitude of industries such as electronics, semiconductor, paper manufacturing, metal stamping, and also plastic injection. Let's start off with our first presentation, manufacturing execution system and overall equipment efficiency. The screen is yours, Dr. Chua.
All right, thank you very much, Mr. Travistan, and very good afternoon, everybody present here this afternoon at the MPMA PLASTECH Month webinar. So my slide should be popped up right now and it should be on full screen, right? So hopefully everybody can see this as a full screen now. So my name is Dr. Chua and I represent the Malaysian Smart Factory 4.0 at the Selangor Human Resource Development Center. We basically support many industries with regards to their digital transformation initiatives, right? And this afternoon, today, I'll talk about manufacturing execution systems. What is it really all about, right? And alongside with a lot of distinguished speakers here today, I believe they will also share in more in-depth, right, on their systems that they are able to support you when it comes to MES execution. And I will talk a little bit more on OEE as well. Basically overall equipment effectiveness. This is basically what we all aim to strive, right, when we want to achieve better productivity and many others, right? And the last part of what I'll cover on today is also how we as as we journey through this digital transformation journey, it's always important to acknowledge that some of the strategies could be more bite-sized, right, and hence more sustainable and scalable for the future. And that's what I will cover here this afternoon as well. Right, so a very quick introduction on this slide on Industry 4.0. What is it all about? Generally, industrial revolutions have been around for many years, right? We are up to today, we are now at Industry 4.0, right? And if you think about it, Industry 4.0 is not a new, it's not a new term anymore, right? It's actually been around for 10 years, right? Since it was first talked about back then, right? Back then in 2011. Now, why has Industry 4.0 taken that decade of 10 years? And up to today, we are still talking about this, trying to get more and more industries on board on this journey of Industry 4.0. It is because IR 4.0 is more about a journey, towards productivity, right? It's more about how we utilize data, right, to create more intelligence within our manufacturing operations. And it's no longer about automation anymore. It's now talking about autonomous systems, right? Putting the intelligence to your factory, right? And this creates rise to many possibilities that industries can take advantage of, especially when it comes to decision-making processes, projection and planning, reduction of waste, right? Optimization of costs. And this is really what Industry 4.0 is all about. Really creating the wealth of data and making it work for you, right? And with a lot of data and information that you get on a day-to-day basis, right, you gain a lot of knowledge. And when you start to have wisdom over your operations, that's when it really helps you to drive better productivity, right? I've worked with several industries that, before they implemented real-time data collection on their shop floor, right, there were many gaps that they were not able to see, right, what is happening at their shop floor. But once they implemented these kind of data-driven strategies, what happens is that they were able to see what was happening at the shop floor. They were able to identify how many times my machine is down in a day. Did my operator take a longer tea break today, right? Or did they start late during production? Why is it taking so long to do changeovers? This is where data creates wisdom for the companies, right? And by just utilizing data alone, right, you actually get to save a lot of time, because the only constant in a day that we have generally is time, right? Every one of us have 24 hours in a day, right? In your production shift, you have, let's say if it's 8 hours, you can only do 3 shifts in a day, right? So the whole idea is minimizing unproductive time, right? The moment you have unproductive time, it's wasting time. Anything that's called waste, it's basically no value, right? So any time delays in your production floor, that's what you want to reduce, right? You want to reduce anything that is unproductive. So by putting in data, you are able to get better insights. You get to analyze things faster. You get to make decisions faster. And obviously, the last part will be being able to project. That's where you are able to take action faster, right? And all this time delay over here that you see, right? Any time delay, or what you want to put is you want to minimize that. You want to narrow down that time delays. You don't want to waste time, right? So having technological elements such as real-time capabilities, really looking at your data, putting in analytics when you have intelligence, decision support systems, and vertical horizontal operation processes, that's where you really save time, right? And that kind of integration across your whole automation pyramid, that's what you should aim to look for, right? And this helps to effectively minimize any form of time delays and cut off any unproductive time throughout your manufacturing operations through technology integration. That's what Industry 4.0 is really about, right? And when you look at the whole automation pyramid, generally, you look at it, when you talk about Industry 4.0, it's not just, okay, I have an ERP and then that's about it, right? Or I have an MES, that's about it for Industry 4.0. It's really about integrating from the field level, the bottom level, the control, the supervisory level, the planning level, and then the management level. The vertical connectivity is important, and also the horizontal connectivity across your machine-to-machine communication is also important to take note of, right? And of course, the key term of manufacturing execution system helps to actually bring some components of that together, right? Basically, you are putting together, the connection between your orders, your scheduling, and then it needs to connect to the shop floor so that you are able to monitor and synchronize the execution of physical processes in real time, right? So when you start to implement your MES systems, you need to look at the core features of your MES, right? And usually for core features, we'll look at work order management, right? That's one key important core feature, right? Scheduling, right? If you don't have scheduling, that's going to be a bit messy, right? Real-time scheduling, meaning to say you're able to adapt to changes, right? OEE, really monitoring your data on a real-time basis. Now, I have met industries that calculate OEE, but that's on pen or paper or on their whiteboard, which generally is not really real-time, unless you are really getting one particular supervisor to take a WhatsApp photo every hour to show you your OEE every time. Right now, downtime tracking and management, this is also an important factor, right? If you don't know your downtime, or if you don't know what contributed to the downtime, then you're basically firefighting every day, right? Now, then the last part of it is quality management. And this, I believe, are core features that MES systems can provide. And this is how you can structure your manufacturing operations towards this, because there's a lot of features available when you integrate MES and ERP. So it's always important to outline what are the core features that you want for your particular manufacturing industry, and that's what you should focus on. Now, the thing about MES or ERP systems is not so much about the features in overall, but what I've noticed is that when it comes to implementation of these kind of systems, right, understanding your process is very, very important. And what I mean by understanding processes is you need to know from start to end, how does your process look like, right? And a lot of departments or a lot of people that I met, some of them don't even know the processes well enough, right? And there's a lot of missing gaps, or there's actually a lot of repetitive work in that process. So when you start to outline your processes in place in your factory, be it, finance process, HR, work order process, purchasing, supply chain, there needs to be a proper line of processes, right? So that when you start implementing these systems, you need to talk about workflow management. You need to talk about workflow decision-making processes. That's how, your MES or ERP kind of integration will actually be very smooth when it comes to that kind of deployment, right? And when you start to look at that kind of integration, you need to start to see how it will integrate with the shop floor, right? So that when at a shop floor level, you're able to execute your orders effectively, right? You can control your systems almost instantaneously. You're monitoring your production on a day-to-day basis in real time. So this is how you want to see that kind of seamless integration across the automation pyramid. Now then, what value does OEE bring then? Now, MES can tell you, okay, you have work orders, you are able to schedule, you're able to plan accordingly, you're able to execute it. But one big component about that is also OEE. Now, what does this really tell you, right? OEE stands for overall equipment effectiveness, right? And it's a factor of 3 different, parameters that you will measure, right? Which is your availability, your performance, and your quality, right? So it's all about looking at the equation of effectiveness, right? And assuming that you think that your production is doing very well today, right? There's very, very minimal downtime. There's very, very minimal parts rejection, but maybe your performance is not doing as good as it seems, right? So assuming a simple calculation like this, right? In one day, assuming you have 8 hours of production, right? But you're only productive for 6 hours. The other 2 hours you are setting up, you're doing changeovers. It is considered as unproductive time. Therefore, you have lesser hours that are available. Now, let's say your machines are supposed to run at 100% capacity, it's supposed to run 1,000 pieces, but you're only able to run 700. You are only at 70% capacity, right? And quality, say you're perfect today, or you're almost perfect, you have 96%. Now, it looks good from an overview perspective of components, right? Availability is 75, performance is 70, quality is 96, but your overall OEE is 50%. Now, this 50% is not, it's not advisable. You need to actually improve it, right? Because overall, you're only 50% efficient or effective, right? Your machine is only producing at 50% capacity. But what OEE can tell you, from measuring 3 different parameters, you are already able to review 6 big losses in your factory operations. Now, what are the 6 big losses? Your breakdowns, right? How many of us really know your frequency of breakdowns in a day for your machine, right? How many of us really know how long it takes to set up a machine, right? During the changeover, during the setup process, are we tracking that? And if we are we really going into granular details on why is it taking so long, right? Then we talk about idling or minor stoppages. Some production systems or some machines, maybe it keeps on stopping. When you stop, then you need to fix something. When you stop, you need to fix something. So these are minor stoppages that contribute to losses. Then your machine speed. Sometimes over time, your machine has wear and tear. It starts to slow down, right? Due to mechanical parts failure, right? And that is also something we need to track, because sometimes we need to see, if we are really operating it at an optimum level. For example, product A, right, is supposed to be a 10-second cycle, right? But suddenly you start to see the cycles only every 20 seconds instead of 10 seconds. Overall, cumulatively, it will affect your overall performance for the day for the same product, right? Let's say you inject every time it's 10, used to be 10 seconds, now it's 30 seconds, right? So these are things that you can track. You can already start to monitor and you start to see when your machine needs some maintenance, for example. And of course, the last part will be, quality. You talk about defects. You need to monitor defects. You need to monitor your startup losses, especially when you start to put in your mold and you start to inject. I'm pretty sure there are some startup losses, right? These are areas where there needs to be some form of adjustments, and that's what you want to count as well, right? Because it's considered as wastage. So a simple example of how you can tap signals from your machine through OEE is, understanding where these signals come from, right? Understanding how to pull that signal, right? For example, you want to look at availability, you can pick from the tower light. You want to look at performance, you can pick from the sensors. You want to look at quality, you can pick on either you have push buttons or you have sensors to determine quality issues. Then the next part of it, a simple example would be to use technology, hardware, like gateways or ironing technologies to just tap data from the machine, right? Nowadays, a lot of machines that I see are legacy, right? Some are 10, 20 years old. I've seen a 30 years old machine as well, but it's still working as good, right? Just some minor, tuning or minor touch that you need to actually make it run smoothly, right? But essentially, these machines are still doing its work, right? So what you want to do is to be able to tap data so that you can monitor them, and understanding what kind of signals you are collecting is the core, right? To getting the signals from the machine. Either is it digital or is it analog? So these are things that you can identify. Or if let's say you have a process that is not using any machines, it's a manual assembly process, it doesn't matter, right? What you need to do is automate data collection in your factory floor, right? I've seen companies where, at a manual assembly, just to calculate how many parts they are producing, they are writing down on a piece of paper, right? Every time one part pass, they do one line, and another part pass, do one line. What if you can digitize that process? What if you can put, a simple tablet and just click on buttons, right? So that it actually counts, it actually can show in real time to the supervisor or through a dashboard what is actually happening. So these are how you can generate data from manual or semi-automated processes as well, right? And once you get there, build your dashboards. So this is what generally we would do, is to advise industries. Once you get the data, build the dashboard, see what is happening in your line, start to monitor it, start to really see how to support, these kind of downtimes, how to make it better. And from day to day, when you start looking at the trends, that's when you start to see, hey, I need to do something, right? And this is how having data will create you a lot of wisdom, right? So you can start to move from your typical OEE, if you're at 60%, now you want to aim to be 85%, right? Or even better, so that you can actually minimize your total cost of losses, right? Cost of downtime, performance issues, quality issues, and really use the personnel that you have to drive a deeper analytical strategy to help you to improve your production system or processes in your line. So instead of firefighting to try to meet orders, now you're doing it more strategically. You are able to use data to back your decision-making processes. And that actually gives you a better lead time for you to plan for any abnormalities, right? So when you implement these kind of systems, you improve machine utilization, you improve performance, you have better production insights, and many, many others. There's a lot of benefits when it comes to implementing systems like this. And this is where many companies will drive better value from these kind of systems.
Dr. Chua, sorry, you have 5 minutes more.
Sure, no problem. Thank you. So the main question mark over here is, when we look at the overall integration, 2 questions you need to think about. How do I establish communication across the automation pyramid, whether horizontally or vertically? And how do I ensure flexible, scalable integration across? So when you start to implement systems like this, this is where you need to consider these 2 questions, right? And when we look at industry applications, we always try to go bite size, right? Start with the simplest application first. Start with a small project, right? Focus on scaling up through, operational technology, information system technology, and the digital factory. This is how we do the smart factory concept, right? Whereby technologies are modular, scalable, flexible, and compatible. This is where many industries will gain a lot of value from technologies nowadays because of this concept, reducing complexity and the cost in overall. And when companies understand their payback period very, very well, and they can achieve it within less than 3 years, they are very much, have a better buy-in when it comes to transforming their operations. And this is how you can start to invest in technology. Build your roadmap. This is the number one rule that we always tell many companies. Start by building your roadmap. Have proper leadership buy-in. That's the first step. Build your own Industry 4.0 ambassadors. You need a team to lead your projects in your factory. It's really necessary, right? You wouldn't want to implement systems that people don't use, right? So this is what we always aim to try to help build domain expertise and build your people, right? And go for it in a step-by-step approach, right? You don't need to do everything at one go. Start small, scale big. That's what we always say. Start with level 1, collect data first, slowly move up, and one day you will reach analytics and even AI. It's doable, right? So we start at level 1 and then slowly scale up to level 6, right? And this is how you can actually see the progression from a shop floor perspective, right? Level 1 at the bottom, collect data, visualize, store, formulate OEE, do your analytics. And if you really want to know how to do that, right, attend programs, understand how to integrate these systems, understand how these systems work, right? Get your people involved, get your people motivated from level 1 to level 5 or level 6. And then focus on continuous improvement every day. This is what we call digital transformation through a Kaizen approach, right? Kaizen is a very, very good methodology of continuous improvement. And we do encourage industries to look in this kind of pathway where it really empowers the people to scale up, right? One thing to note also is to learn from industry partners or learn from industry practitioners on how they successfully started their journey. So this is one example of a company that started their digital transformation journey and then slowly how they're scaling up their operations. And from learning from each other, definitely we will understand more, right? Focus on transformation strategies that are flexible, scalable, modular, and readiness to scale at any time. This will give you a lot of maximum value creation, and that's where you can scale up more effectively. Now we are open for visitation in the Malaysian smart factory. So if you do want to come and see it live, operational, let me know. I can bring you here and I can host you. Otherwise, a virtual tour is available, right? And this is how we can share with you what we have at the Malaysian smart factory, right? And we have a lot of content. Nowadays, we share a lot of new knowledge, and we hope to engage more with every industry to see how we can support you in your journey of transformation. And with that, that's all I have to share this afternoon. Thank you very much. If you do need to ask any questions, I believe at the end we can discuss further. Thank you.
Okay, thank you, Doctor. Now we shall start with our second presentation. Production scheduling for plastic injection molding factories. Stephen, you may start when you are ready.
You all can see my slide, Mr. Travis?
Yep.
Okay. Thank you, Mr. Travis. Good afternoon, everyone. I'm Stephen from reimagine. For this session today, I'm going to talk about production scheduling for plastic injection molding factories. First, let us take a look at the current situation for plastic injection molding factories in Malaysia. Many of the plastic injection molding factories are making many different types of products where they need to configure their machine for many different jobs involving many changeover that typically operates on low volume, high mix situation. Now, in this kind of situation, you need to be very flexible. One machine can make 30 to 40 different type of product. It just depends on what mold you put on the machine. Also, there are factories that operate on limited quantities of ancillary equipment, such as limited quantities of power cutter, limited quantities of mold temperature controller, limited quantities of chiller, and so on, where these limited quantities of equipments are being shared among the plastic injection molding machines. Therefore, you need to quickly configure the machine for many different jobs. You need to do quick changeover in order to avoid incurring a lot of machine idle time loss. Production scheduling in manufacturing is one of the difficult job assignment to do, especially if you operate on the low volume, high mix situation. So it's important to get it done right. Because if any parts of your production scheduling is off, then downtime and delay will happen. In most of the manufacturing factories, the production planner are using Excel to plan and schedule jobs. After you have scheduled a job using Excel, you then proceed to prepare all the necessary resources required for the job that you have planned. Your mold technician will prepare the mold. You prepare the materials. You prepare the currents such as master batch, pigment, and so on. You prepare the ancillary equipment, rubber attachment. You prepare the packaging materials such as PE bags, boxes, PVC compartment trays, cardboard separator, layer pad, and so on. You prepare the mold temperature controller, chiller, dehumidifier. And while you're busy preparing the resources for the job, your machine setters have spent 1 hour installing the mold on the machine. However, just when you're about to start production, you find out that you do not have the power cutter available because it is still being used by the other machine. Now, without the power cutter, you could ask the operator to use hands to do manual cutting, but this will prolong the actual cycle time. Also, probably after 5 hours of manual cutting, the operator could fall sick the next day and not coming to work the next day because of sick leave. So after you have evaluated all options, you then decide not to run the job. In the meantime, you have already prepared all the materials required for the job. You have already prepared all the packaging material. You have already prepared the rubber attachment, mold temperature controller, chiller, dehumidifier, and your machine setters already mounted the mold. So end up, they need to spend another 1 hour to dismantle the mold. At least 2 hours are wasted because the power cutter is not available. So all the effort you have spent in preparing the resources are all wasted. So in the meantime, the production planner has to quickly rearrange new production schedule using Excel. However, Excel is not flexible when you are faced with the rapidly changing situation at the shop floor, especially if your factory operates on the low volume, high mix situation. Well, if your factory operates on the high volume, low mix situation, the other end of the manufacturing continuum, for example, there are some factories that only make one type of product for the next 2 years or 3 years. Then you do not need a very flexible manufacturing operation because you are making very few products. The line are dedicated, so there's no changeover or probably very little changeover. But for the low volume, high mix situation where one machine can make 30 to 40 different type of products involving a lot of changeover, Excel is not flexible for this kind of situation because it lacks the capacity to analyze high volumes of data due to the rapidly changing situation at the shop floor. By using Excel, the planner needs to spend extra time trying to pick up all the data from the schedule, because the schedule is not integrated with the resources that you have. It is not integrated with the jigs and fixtures that you have, for example. Therefore, using Excel is slow because it is labor intensive. Also, Excel is error prone. They are vulnerable to mistake that can cause confusion, which will slow production. So while the planner is busy with replanning the whole schedule using Excel, you are faced with costly production capacity loss. Production capacity loss because of machine idle time due to no resources. In this case, you have already set up the mold, but the power cutter is not available. Other possible situation could be you have already set up the mold, but the materials do not arrive on time. This can also cause machine idle time loss and results in costly production capacity loss. Let's talk about the cost of machine not being able to operate. How much it will cost you not being able to operate your machine. If you can save 10 hours a week per machine, let's say it is a 100-ton machine, the typical charging rate by OEM part manufacturer for a 100-ton machine is about 30 ringgit per hour. That's 300 ringgit of production capacity loss a week for a 100-ton machine. For a year, you multiply that by 52 weeks, that's 15,600 ringgit of a year of machine idle time loss. If it is a bad case scenario for 10 machines, you multiply that by 10, that's 156,000 ringgit a year of machine idle time loss. That's how much you waste on production capacity in a year. That's how much money you lose in a year. That is why you might want to consider shifting your production schedule out of using Excel. It will be helpful if you consider using a schedule system that is specifically designed and tailored to the plastic injection molding factories, where the schedule system is able to generate new schedule based on available production capacity, based on available production resources, and also based on your client's order. The schedule system allows you to register the working patterns that apply to the production floor. You can register the working date range pattern and the working time range pattern for the factory. For example, you can register a full day 24/7 working pattern for the production floor into the system. Or for example, you can register a 4 days per week working pattern with tea breaks between what time to what time each day, or any other types of working pattern that apply to the production floor. The system allows you to register all the packaging materials that are used for packing the finished products. It can be plastic bags or carton box, for example. You can register all the customer of the factory. This will be used to link to the product type and mold owner related to the customer registered in the system. So this is useful if you are OEM part manufacturer. You can register all the different types of raw material to be used in the factory. You can register all the different types of ancillary equipment and the quantity of each types of ancillary equipment inside the factory. For example, there are 5 standard conveyor available in the factory. There are 3 units of mold temperature controller available in the factory, and so on. You can register all the different types of machine that are available in the factory. For example, 10 units of 100-ton machine, maybe 5 units of 100-ton machine, and so on. So in the future, if you add another machine or another equipment to your factory, you only need to add the new machine or the new equipment to the master setup of the system. You can register all the different types of parts or products that can be produced in the factory. So with all this information registered in the system, the schedule system will be able to generate new schedule based on available production capacity, based on available production resources, and also based on your client's order. The planner will be able to check the delivery date of new order based on the current production ordering condition in the factory. This is the screenshot of the schedule system. I will show you some interesting and helpful feature of the schedule system. As you can see, there are some orders already registered in the schedule system. If you want to add another new order to the system, press the add button over here. You then enter the information for the new order, such as order number, part, planned quantity, wastage, deadline, new order, remarks if required, and then you press the save button when you're done entering the new order information. Now the new order has been added into the system. In this case, I have selected a list of 5 different orders that I want to schedule. I then proceed to press the auto schedule button for auto scheduling function by the system. All the selected orders are now scheduled. You can move the mouse pointer to the order to check the information. When you mouse over the order bar, it will show the relevant information related to this order. For detailed information, double-click on the selected order to see it. Now you can see more detailed information regarding this order. The schedule system has the drag and drop scheduling feature, allowing you to drag a schedule order to a new time slot that you want. The system is able to generate new schedule in order to meet specific delivery date or deadline requested by the customer. Let's say you have already scheduled this job using the schedule system, and later you receive a telephone call from the customer requesting you to change the delivery date for this job. You can drag the order to move it to another time slot that you want, and the system will automatically rearrange the whole production schedule for you. This will make the planner's job much easier, as they can quickly see the effects of rushing an order and how it will affect the other scheduled jobs, so that they can then inform other customers regarding the newly adjusted delivery dates. Therefore, the schedule system removes the hassles of replanning the whole schedule when you need to do some urgent order first for the customer. The schedule system also helps reduce planning mistakes when the resources such as mold temperature controller, chiller, dehumidifier, and so on are used by the other orders. This is quite costly when the mistake is only discovered after you have already set up the mold on the machine. For planning downtime for the resources, you can use this module to select and disable the working time of the machine. You can select and disable the working time of the mold. You can select and disable the working time of the ancillary equipment, and so on. The system will then avoid using the same resources when you're using the scheduling function. To add a new planned downtime for a resource, press the add button, then select the resource type, and then set the date and the time range. And you can add remarks over here too, and then you proceed to press the save button after you're done entering the planned downtime information for the selected resource. It is able to regenerate new production schedule when certain machine is down or certain molds are not available. This is the mold service module. This module will track all the orders they are completed and calculate how many shots have been accumulated by the molds. If the accumulated shot quantity is over the target shot, the row will become red in color. When the accumulated short quantity is over the target short, the planner is able to alert the maintenance department when certain molds have exceeded their maintenance thresholds. The system would then avoid using the same mold when you are scheduling for a new job. Only after you have serviced or repaired the mold and updating the mold service and mold repair information into the system, then the accumulated short count will then be reset to 0 by the system, so the system can now assign the mold when you're scheduling for a new job. This will definitely save the planner a lot of time when they're planning resources for a job. The schedule system can be integrated with MES, which is Manufacturing Execution System. This will allow you to track, monitor, and collect accurate data about the production cycle for machine output monitoring. The system can be integrated with Inventory Management System for material inventory level monitoring. This is to ensure the material inventory is always sufficient for the plant schedules.
Stephen, sorry, you have 4 minutes left.
Okay, thank you.
Thank you.
The system can be integrated with CMMS, which is computerized maintenance management system for maintenance alert of resources. The schedule system is a web-based software system. Therefore, we authorize user login and password. You can access the schedule system through the internet. By using production scheduling system in your production planning, it will help improve production planning efficiency and help avoid production capacity loss. I finished my presentation. Thank you.
Thank you, Stephen. And now for our third presentation, increasing performance with supply chain management. Please welcome Daniel.
Right. Thank you, Travis. Good afternoon, everyone. Let's jump into the presentation since we have 20 minutes. You can see my slides there, right? No, sorry, not yet.
Not yet, not yet.
Not yet, screen share. Sorry.
Yeah, it's up.
Yeah. All right. So I'm Daniel from Monitor ERP System, and today we're going to talk a bit about supply chain. The other gentlemen have covered production planning and MES, which also is part of our system. So maybe our name ERP system is a bit misleading, but I will come back to that. Just a very quick introduction of who we are, and then a little bit try to illustrate or more look into what actually flows through a factory before we jump into the systems. I hope I will be able to show the system a bit, even though we only have 20 minutes. Later we take questions, I think, in the end. We are a Swedish company, founded in 1974, have worked with manufacturing since then. Today we are around 340 people in different countries. We have around 5,000 customers who all are in manufacturing industry in 30 countries. Malaysia, I moved here 9 years ago, so I have lived nearly half my adult life in Malaysia, so I'm pretty local by now. We have around 100 customers in Malaysia and also some in Singapore and Thailand and Vietnam and Indonesia. But so far we are very busy in Malaysia, and that is where we have our Southeast Asia headquarters. We are around 40 people right now, and we are trying to expand as much as we can. Monitor, our key strategic standpoints are from day 100% manufacturing. So that's why I will say later it's not just an ERP, it's MES, warehouse management, quality, tool management, everything in one system. But since we only have one product and have done it for 40 years, it has been a very standard system. So we don't need to customize, or we basically don't need to integrate with any other MES or barcode system or whatever. So that is our niche, which make it easy to implement, easy to use, cost effective, since we focus on small and medium-sized manufacturing companies. We cover basically all kind of discrete, also some process, but I would say majority is discrete manufacturing, metal, plastic, electronics, a lot of automotive. Yeah, basically everything that have some processes and a bomb, I used to say. If we're just going to name some local references, since this is MPMA, maybe we bring up PDI. Mr. Travis was our first customer, actually. Emico, Secoplas, Massing Plastic, LH Plus, GE Shen, Polyparts. Exxon is plastic. So we have a good bunch of plastic companies in Malaysia. We have worked long with MPMA, so quite good coverage of the plastic industry in Malaysia. Have learned a lot. All right, the ERP system for manufacturing companies. There is a lot of misconception, I think, in many companies we visit or many experts or everything. ERP, people think is for finance, but there are ERP systems that are very focused on manufacturing, not only monitor, there are a few others, which makes it a complete package. Everything a manufacturing company needs should be in our system. So that is what we try to add on all the time together with our customers. So we can cover every process throughout the factory. I will not go into details here now. I will jump into system later, you can see, but it's basically a very complex information flow. Everyone in manufacturing knows there are a lot of headaches, meetings and firefightings and finger pointing and a lot of things flowing through the company. So I got the idea I will use a very old slide or not so flashy slide, but I think it's quite illustrating and easy to talk around. So we later understand when I jump into the system. This we used to use for students in universities and things. So, but basically we have a factory with different departments. And as our system is built, we have a module or we have packaged it under different menus for each department, you can say. We have customers, we have suppliers, and there comes monitor modules. I will jump into system soon. But basically, everything we have some demand in some way, comes from orders, could be forecasts, could be quotations that we think is pretty near, so we need to start to plan maybe already. If we think about this in a company where we sit in Excel or maybe different systems, this fast becomes very complicated, and we waste a lot of time sitting and planning and replanning and discussion, coming home late, can't spend time with family. But basically we do some kind of requirement planning. How you do it, if it's system or Excel or morning meetings, doesn't really matter, but in some way we plan it. What do we need to buy? Someone should tell purchaser that we need to buy something and we need to buy it by then, we need to receive it by then, and so on. So we place some POs, we send it to suppliers, could be email or electronically, doesn't matter. Suppliers will deliver it, we receive it into our warehouse. Every step here is a lot of different documentation and information exchange between people in some way. If it's paper or digital, doesn't matter, but there are a lot of information flowing. When we also discuss, we also need to know what to produce. So in some way, someone must tell the production planner or whoever is responsible for production that now we need to produce something. We need to create job orders. We need to plan our job orders. When we have planned it, we need to get that information down to the shop floor. We need to maybe do more priority planning, the last minute changes and so on. But if we have a good master plan, hopefully we don't need to priority planning too much. Down on the shop floor, a lot of information need to come up to the other levels. If we look on the pyramid that Dr. Chua showed, But in some way, we need to know what's happening. We need to know how much time we spend, what quantities, what material do we consume, what reaction, what indirect time, how long time is our machine down of different reasons. That also incur stock transactions. We must in some way track what we consume and what we produce, and back and forward, WIP, finished good, storage, etc. This also creates a lot of data for our follow-up. Do we follow our planned unit times or setup times, or do we take longer than planned, and so on? We also keep track of our workers. How much absence do they have? What do they do when they are attendant? Do they come late, and so on? When we're done, we need to deliver. Deliver means we need to send invoices. We also receive invoices. We need to approve invoices, which in the end links to the accounting. So this fast start to be pretty complex. And the more we grow, the more people we have, new people, we better have control on this. Otherwise, we can't run our company efficient enough to be competitive. So we have stock reporting, we have inventory, we need to keep track of our tools, we need to calibrate them, send them for service. We have non-conformities, we get claim from customer, we get some bad items from supplier maybe, and internal. So once we start to run this, if we don't have a system, we also need to do all this manually. We need to report in some way. We need to have statistics. And this often takes a lot of time and a lot of manpower. Admin clerks sitting, preparing different reports, sending to the boss every Friday evening. If we have a system, this comes automatically when we report. This I think I skip, but basically, people think that ERP is super complex and everything, but it is every practical or physical step in your production factory that we try to digitize. So it's no rocket science. It's all, everything is there together in one place. Since we have limited time, I will not talk much here, but I think you get my point. A lot of activities, a lot of different information that need to be traced somewhere. Data I would also touch quickly, because also a misconception is with ERP is you need so much people to maintain the system. I would say it's the opposite. You need less people after a while running the system, but you have basic information that you basically never change. It's one-time job or you add it in and it's there. Maybe sometimes you change it. Same with basic data, customer, suppliers, machine, part numbers, BOMs. You can also import this if you want. Then we have different registers. We need to create customer orders, manufacturing orders, quotations, invoices. This is something every user work with every day, and that creates great statistics, and everything is in real time. So that is basically quickly what a complete ERP is about. So then I would like to jump over to the system. Now, I don't know, I have around 10 minutes left, maybe. I could spend days to show this one, but I have choose a few ones. This is how monitor looks like when you log in. Since it is a system for everything in a company, it also covers your capacity planning, shop floor, detail planning. We saw previously the scheduling, drag and drop, detail planning. All this is also in the system. Based on your function, you can have different components on the dashboard. All this is standard. You just drop them in. It's nothing we need to customize or anything. Up here we have the modules, manufacturing, purchase, sales, and they are packaged into different boxes in a flow where it flows practically. You get customers, you take care of them, you quote them, we get orders, we deliver, we invoice. Statistics and account receivables. Basically, this is how it's built up. In production or manufacturing, you have a lot BOM and routing. I will come back there. That was the reason Travis bought our system, he said. When he saw BOM and routing, he got it. But here you release manufacturing orders, you plan them, you have loading plan, priority plan chart, pool plan, material, pick list, subcon. You need to report output in some way. Is it manually or automatically? Signals from the machine, doesn't really matter, but in some way we need to report our manufacturing orders. A lot of follow-ups, work center settings, tool and maintenance. So tool and maintenance, basically every time we sell to a plastic company, we need to take care of our molds. We need to control cavity. We need the cycles, how many shots have we run before we need to maintain and so on. So that is all built in our tool and maintenance. BOM and routing, we start there quickly, even though maybe it's boring, but it's basic data that must be there. If system don't have this detail enough, you can forget good production planning and material planning, I would say. If we can't tell the system detail enough how we produce certain part, we still need to use something else to plan properly. So I think this is maybe it is the heart of our system at least. So here I have some item. I will produce a small part storage cabinet. Here I can see different levels. This is the top level. I have assembly and packaging. To produce that one, I have my material down here. So I have a few semi-finished items. Plastic bin I need to produce. I have my labels. So you also include all the packaging material. You can have it very detailed in packaging, different levels, outer box, inner box. But basically we set up time, unit times, queue time, overlap, everything to really detail how it actually is produced. So here I can easily maneuver and see this is the top item, this is the semi-finished where I run injection molding. I run it in this Arberg 80 ton, it seems like, cool. And I need some PP, how much and so on. So this is how all is linked. Once this is there, we have a little bit more basic data before we do more fun things, but we also need to set and tell the system what kind of capacity and so on we have. So if I take a Arberg 150 ton here, system must know how many machines per order, availability factor, what is the basic time, what is the cost in this machine, labor, machine, overheads. So this is more for costing. We need to know, we can put schedules and so on. We can put staffing factor, maybe one guy run 3 machines and so on. When we have those two, we also, of course, have a lot of part master data. So since this covers the whole company, we have made it like this. We have one place where you maintain all the master data. General, different categories and so on. Planning is very important for the MRP. What is our safety stock, MOQ, rounding factor and so on. Is it order oriented? Is it lot for lot? Is it link requirements? Different settings for different items and different products you produce. Planning window is a great overview where I can see all the open orders related to this right now. And then we have purchase, if it's a purchase item, sales prices, and so on. All information in one place. Enough with basic data maybe. So since we have all this in one system, what can we do? Now this is supply chain. So I have choose a few of my favorite functions maybe. When I register a sales order, if you think of your current situation. You sit in morning meetings a few hours maybe. We receive a new order. When can we deliver? How many pieces can we deliver and when and so on? This the system can tell us immediately, since the system knows everything. Down on the shop floor, know exactly what's going on. If I want to deliver this end of November, let's say, system tell me earliest 7th of December. I can see why directly. I need some PP, it seems like. If I want, I can dig deeper. How does it look for PP? This is my current balance. I will use it for this order, this order, this order. Here I have a new PO coming in, and this is my balance later on, and so on. If I'm gonna deliver, if customers say, what about 10 pieces and so on? Same date, I look again. Could be other reasons. Now I will have some issues with my plastic bin, semi-finished goods, it seems like, and so on. This is extremely valuable, I would say. You save a lot of time. The person register orders immediately have a very good understanding of how it looks. 100 pieces I can only deliver in March because my laser cut looks full. I can dig down and look more. Here is the system putting in my operation, and I can go down and see. Obviously, this one is fully loaded until 18th of March. Then we need to replan and so on, maybe, but that we do in other functions. So this one I think is very strong. I haven't seen in any other system, not in real time like that. If we talk MRP, which probably is the heart of supply chain management in an ERP, but when we have demands in the system will calculate when you need to buy, what to produce, and so on. So if we take that, maybe next one here. Under purchase, I have something called purchase order suggestion. So the system will tell me all the time. It runs every 20 minutes in the background. What do we need to buy? As a purchaser, I would go here and see, this is the items I need to buy. I could filter, of course. Now I see everything. Now it's grouped by supplier. I see from this plywood, I need to buy these items. I need to release PO by then because I need it by then, and so on. Here I can immediately tick and release POs. Same thing you have, or also if we look, it can also reschedule existing POs because it might be that.
Daniel, sorry to interrupt. You have like
5 minutes.
1 minute left.
1 minute.
Yeah.
I thought you were telling me when it's 5 minutes. Okay.
You're busy talking.
Then we need to jump a bit. We take another one. Order list purchase, I think. I show 2 more then. Order list purchase, check delivery time, I think is nice. Do we have any POs that will cause consequences? If our purchase orders are late, will we get delayed in production that also maybe will cause issues on delivery? So I think this one is also very strong. Now when I'm in a hurry, it took a long time, it seems like. I just dropped it. Maybe, there, sorry. Then I will see that of all my open POs, 12 will give me consequences. These are the items. Paint is late apparently, which will affect this bookcase manufacturing order, which will affect this bookcase sales order. And it will also tell me when I can deliver my sales order. So different tools that helps us really be, how to say, before problems occur, we need to take actions. Same on the sales side. I don't know, was that 1 minute or? No, my system is not friend with me when I'm in. Kind of. Same on the sales side. All our sales orders, isn't any that will be delayed. same there. We have 30 orders that will be late, it seems like. I can go in and see what it is and filter, maybe look on maybe what customer we need to prioritize and so on. Try to act before it happens. So unfortunately, the time is up, it seems like. If you want to use barcode or QR code or whatever for different transactions, you build your own labels and everything. It's no magic with barcodes. There's no separate systems or anything. All in the same system. All information is here. Maybe that's it then. If you want to know more, just let us know and we can run demos online. If you want to see, I skip this then. Please contact our existing customers too. I think it's okay. Travis will answer, I think, hopefully, and say hopefully something nice. But Malsing, LH Plus, PDI, great examples of pretty happy customers, I think. So thank you very much, and please check out our website or just give us a call or email and we can book a slot and discuss more with you and show more of our system. Thank you.
Thank you, Daniel. As for our final presentation, optimizing the value and performance of machine and production through Lean will be presented by Mr. T. Please go ahead, Mr. T.
Hi. Thank you, moderator, Mr. Travis Tan. I'm sure towards this end of the pandemic, every manufacturing is getting a little concerned about how we are going to survive in the near future if there is another similar tsunami coming. So most of us will start to plan on cost cutting as the first option, but we know it won't work. Okay, it won't work, and if we did not strategize them right, yes, I say the keyword right, as planning and executing in a proper way, proper manner, without affecting the process, the machine flow, and also the human factor. Okay. Ladies and gentlemen, I'm indeed honored to share my Lean experiences and know-how with all of you, and thank you MPMA for inviting me today. The first three presenter is more onto the software part of it. I will be covering more on the hardware in terms of execution. I'm confident that all manufacturers understand what are the main values in your manufacturing process. But how often do you or do we know and effectively increase the performance of it? And how many of us actually applying Lean methodology to reduce the waste in our operation and thus optimize the value? Now, Lean in a nutshell means creating values and eliminating waste. It basically means it's a systematic approach to identify. So first of all, you need to identify all the waste or all the non-value added process, all the non-value added process activities through a continuous improvement, or sometimes we call it Kaizen. And sometimes it is rebranded as a operation excellence strategy, or in other words, to the shop floor people or operator level, is called Kaizen. Now, first of all, business as usual. Okay, we have what we call the order lead time from the customer order until we deliver our product to our finished product to our customer. So this is what you call the order lead time, or the manufacturing lead time, whatever you call it, is still a lead time. And between these two ends, we have what we call the value-added processes, which normally accompanied by a lot of waste, manufacturing waste. Thus, a Lean process come with little waste and easily identified by reduction of the lead time. So it's about how we can reduce or eliminate the waste. And when we eliminate the waste, we can see that the lead time will reduce. So this is the way we measure lean. Now, so I want you to revisit your manufacturing lead time, okay? And ask yourself, okay, what are you lean enough? Okay, are you lean enough or not? Okay, so how many days from your order until you deliver to your customer? Okay, and of course, we are manufacturers, okay, especially plastic manufacturers. We can't be comparing with McDonald's, okay, who is now able to serve between order placement or order acceptance to delivery, okay, where you can stand there and you get your McDonald's or your burger between less than a minute. Okay, today McDonald's is talking about a minute. Nevertheless, what is your best? Okay, what is your best? Can we challenge to half it? Okay, let's say now you are talking about your lead time is about 1 month. Can you do it less? Half it. And that is exactly the spirit of lean manufacturing, right? So let's go quickly on what is work elements. Okay, work elements consist of value-added processes. Okay, which is what the customer is willing to pay for you, pay for it. Okay, these are all the value-added. So they are willing to pay for your assembly process, your molding process, and so on. And then you also have the value-enabled. They are non-value added but necessary. Like for example, you need to pack. Okay, you need to move your material from one place to one place. Okay, so this is value enabled, but they are actually non-value added because customers are not paying. They are not paying for this work. Okay, and of course the big chunk will come as non-value added. Okay, or we call it basically waste work that added cost into your operation. Now, most of the time, manufacturers will always focus on reducing the value-added process. Okay, we're looking at the value. We are looking at the value-added process without noticing that there are a lot of operation waste in our manufacturing floor. Okay, and these are the waste that actually indeed the culprit of all the performances and the long lead time for your manufacturing. A quick snapshot on the lean tools. There are many lean tools. Okay, I'm not going to cover all this, okay, but just give you an idea that there are many ways of implement lean in your operation. Okay, and normally this one will begin with the value stream mapping. Okay, on your whole manufacturing process. So we need to map your process and understand where you go wrong, and where are the potential places that you can improve. Yeah, your process. Okay, now. First of all, there are two main elements, okay, especially for plastic, machine efficiency and as well as labor productivity. Okay, and this is where we really need to lean, okay, to make sure that we are as low waste as possible. Now, have you ever calculated your ROI, your return of investment when you pay or when you buy a machine? Maybe $1 million or a few million, $100 million and so on. Okay, have you calculated how fast can it come back or not? The money, does it come back to you or not? Okay, ideally, of course, we will love that our machine can perform bulls and horse, and the Chinese say bull and horse for 24/7, 24 hours a day, 7 days a week, 24 hours a day. So without stopping and without resting. But in reality, we can't. Okay, they need to rest. They need to rest for maintenance, and also it will also affected by sometimes we call it loss or losses. Okay, so the challenge here is, do you actually know how much losses occur at the production floor? Yes, you can use all the system that our earlier presenters shown that, okay, the OEE, measuring your OEE and also all the MES system. Okay, so you need to get all this to really understand it. But while you're not having that system yet, okay, can you do it manually to understand where are your losses? Okay, now here are the key losses for you to measure. Okay, downtime. Okay, I think the Dr. Chua have covered this. I will not cover that again. Okay, and then your speed loss. How often your machine is idling. Okay, and sometimes the machine is because we may set a time, the time for the cycle time, but in actual fact, when you go to the production floor, the operator or the technician actually, they tune it, and you see that it take more than the standard time that you require for your production. Okay, and these are all the speed that we need to measure, and of course your reject. Okay, your startup rejects and your defect from your processes and as well as your rework. Okay, and these are the two main activities that you must install to help you reduce your losses. Okay, the first one is quick changeover. Okay, don't look down on quick changeover because most of the time, most company will have about 30% of your losses come from changeover, unless you are very lucky, you have a high volume, low variety, and then you don't change so often. Okay, but I guess today we don't have that luxury now. Another one is the autonomous maintenance. Okay, autonomous maintenance. Please note that this is different. Okay, this is very different from your normal preventive maintenance, or you call PM, that your technician or your engineers are performing weekly, monthly, and yearly. Right? This autonomous maintenance is very essential for you to maintain, ensure that your machine is tip-top, and it's done daily. Okay? So yeah, you need to look into how to ensure that you install this system inside so that you can reduce your loss. I won't say eliminate 100% because there's no way we can reduce 100%, but you can reduce the losses. Okay, and when we are able to manage and control all these losses, okay, you will see that your OEE, your OEE will slowly climb up. Okay, it will increase. Okay. And the second area is labor productivity, right? Okay, and the trickiest element to improve your labor productivity is on motion. Okay, and here you need to form lean or Kaizen team to actually go down to the floor, observe, identify the ways of each processes. Okay, so like for example, your is a process balance or not? Okay, is your material, the way you put your material, we call it material presentation. Okay, how you arrange your material, all this will not be in the system. Okay, not in the system, but you have to go down to the shop floor. Therefore, you need team, you need people, Kaizen team, Kaizen or lean leaders to go down and take a look, or sometimes we need management to walk the floor to see the problem in the actual issue or actual problem on the floor. Okay, and sometimes you need to implement simple jigs to assist the manual processes. Okay, and for automation, my 2-cent advice before implementing any automation, please do consider to lean the process first. Okay, so I've seen many automation from different companies that I've been working. Or my client, okay, they actually when they design the automation, they actually included the waste into the process design. So my advice is to lean the process first. When you lean the process, and then you say, okay, now it's time to replace the human with automation, and then your automation will be lean automation. Okay, my standard requirement to automation is always do no equal. People say equal or better. No equal but better. And this is what lean improvement policy is all about. Okay, we call it double the good, half the bad. And another area very effective is called the water spider. These are the lean tools that you may not be familiar, but once you implement or once you learn about lean, this is where one of the most effective way to reduce motion and waiting time. Okay, you will also immediately realize the reduction of your WIP in between the processes, and the process will move. Okay, once you implement water spider and so on, you see that your process is going to be moved like a stream, steadily flow into the ocean without much turbulence. Okay, so you can see that your process will be very, very smooth. And if you observe enough, you observe enough, you go to production floor, observe enough, you will be able to identify most of the time our operator are waiting for the machine to end their last steps before they can start working. Okay, so we need to look into all these losses. Okay, and another area here is lean manufacturing always focuses on ergonomic of the worker. Okay, as they are the only workers. Okay, they are only person that perform value added work. The rest of us are not. Okay, we are actually non-value added indeed. Okay, we are playing supporting role, and if we don't help our operator, our shop floor people, okay, how to improve, how to identify the waste and reduce the waste, then who will be helping them? Okay, and they will be very busy doing their work, but they don't have time to go and think, right? And therefore, Kaizen. Okay, the lean culture of Kaizen, or we call it the continuous improvement activities, must be kept alive at all time. Okay, here because we need to ensure that the people going down to the floor, go Gemba is a Japanese word, means that go to the actual site and see. Okay, and then you implement your quick and easy Kaizen first. Okay, those low hanging fruit, you can actually take it out as soon as possible, and that of course will help to manage your daily quality, your cost and delivery issue, okay, on the shop floor.
Mr. T, you have 4 minutes.
Yes, coming to the end. Yeah, thanks. We know most of the company expanded as our business grow, okay, and tracking the process flow into spaghetti chart will help you to further identify your manufacturing waste. Yeah. Now, finally, at all these improvement processes, okay, your machine and your labor will not make any sense at all if it does not make an impact to your financial figure. Okay, normally I will recommend that you start by identify your baseline first and your area of potential improvement. Okay, where are the potential improvement? For example, if your quality is a main issue, then let's jump into the quality. Okay, but if your delivery is an issue, then let's go into that area. Okay, as well as the cost of a waste. Okay, where your losses come. Okay, and that your realization of all your optimization and performance can be justified to your stakeholder. Okay, so we need to look at your process, how much material have been scrapped. I know in plastic injection and so on, we say that, oh, our material can be recycled, but you do forget, the moment we recycle our material, we already lost our opportunity, time of process opportunity, the energy on the machine, okay, that been running, and then the output came out is all lost. Redo again. So all this have to be considered. This huge money. Okay, so don't look at recycling. Recycling means that the more you recycle, the more you lost. Okay, and of course, labor cost, overhead, your e-cost, your electricity cost, because depend on in your manufacturing, how much electricity are you using? Can you reduce it or not? So this is where we consultants come in, lean consultants come in, and we can help you to actually identify, and not only help you, but we work together with your team. We work with your team to teach your team how to identify the opportunity and then eliminate your waste. Okay. Now, finally, of course, a quick one. These are all the clients that I have from Malaysia, from Singapore, Indonesia as well, Taiwan, and also from the China. Okay, so local plastic injection also we have. We also cover not only plastic but also rubber and as well as hotel. Okay, finally, thank you very much. And if you need any information, you can always contact me directly, or you can actually go through MPMA as well. Thank you very much.
Thank you, Mr. T, and all the speakers. Before we go into our Q&A session, I would like to pass the screen to Sujata.
Yeah, thanks, Travis. Okay, before we go into the Q&A session, we just want to do a quick poll. This quick poll is actually to understand and the effectiveness of the webinar. It's also will enable us to understand the areas of improvement for our future webinars. So I would like to request for everybody here, we have 230 participants, to please take part in the poll. There are only 8 questions, and we will give this about 2 minutes.
Sujata, while the people are doing their poll, can I just have a chat with the panelists? Maybe.
Yeah, yes, please.
Good afternoon. I'm Eddie Fong. I think most of you know me. Daniel, we probably haven't met, but you probably see my name somewhere. Thank you, speakers, for giving us wonderful presentations. I know the time is so short. You guys probably have 2 or 3 times more things to say, but we have to control the webinar. But it's very informative. I think there are so many good things to listen to. Dr. Chua, I think, gives a general idea of how to implement MES and how to get OE and so on. I think the scheduling part is interesting. Stephen gave us very specific for injection molding companies. Third one is, Daniel, you've given us a very good run of your monitor system, but unfortunately the time is so short. I know you can probably go for another hour, but we unfortunately have to limit the time. And Mr. T, I think he's very down to earth, or down to the shop floor. The other guys are all theoretical a little bit, but I think lean is where the rubber meets the road, so to speak, and I think it's very good. So the whole webinar today is quite balanced. I hope the participants will actually take the opportunity to ask all sorts of questions, difficult ones maybe also, so that you can get some good answers.
Sorry, Mr. Eddie, I have to interrupt.
Yep.
We have about 51 persons who responded to the poll. Can we have a few more, please? Just a few more. This is about less than half. Can we just have a few more? We would just want maybe about 60% or 70% of the total number of attendees. So
give us the feedback, people, so that next webinar we organize can be better, can be improved, and so on. So need all your cooperation to get all the feedback.
Very easy questions, not difficult to answer. A little bit more, a few more.
Simple multiple choice.
Yeah. Come on, a few more. 62. Those who haven't attempted the questions, can we ask for your cooperation? Okay. Okay, it's not moving. Mr. Eddie, I think we'll end the poll and I'll pass the session back to you to continue. You're muted.
Sorry, you passed to me or passed to Travis?
You were speaking, so that's why I passed it.
I finished my short speech. Thank you.
Okay. Travis, back to you then.
All right, thank you, Sujata.
Okay.
So we shall start our Q&A. So please present your questions in the chat box. So the first question for Mr. Daniel. So I think it's he already replied in the chat, but for convenience for the listening guests, does the monitor ERP replace any current system we have, or can it be linked to our existing system? Example, auto count.
As I said, normally it of course depends what you have, but I would say normally we replace all systems, definitely the accounting system. There is no need to have any separate auto count or UBS, and it's no meaning to have a separate warehouse system or planning system. And sometimes if you already have implemented some MES, maybe it makes sense to keep it if you like it, and then we can integrate. But we normally try to integrate as little as possible, because the less integration, the less issues, especially for SMEs. If you are a bigger company, you normally have a bigger team, maybe of IT people and so on, and maybe are used to work in that way. Then maybe it's make more sense to keep something and integrate. But for smaller ones, we strongly recommend to, if possible, as much as is possible, you try to use one system.
Thank you, Daniel. Okay, based on my experience, because I'm also a monitor user, it will be, it's my preference also to try to stick to a single system, as everything is interlinked. So you won't have data integrity issues, especially from human error or from file error leakage. Okay, I have a question for Dr. Chua. What are the challenges to implement MES that you can see in Malaysia SME?
Okay, I think one of the key challenges is, number one would be understanding your process flow, right? And identifying what are the parameters that you need to measure and also need to be in the MES system. So sometimes the system is already available and it has tons of features, right? Most of the system that I see has tons of features, right? The key challenge I see is number one, to streamline the process so that it's easy for people to adopt it, easy for people to use the system. And most of the time, I think it's the cultural adoption for the industry, right? Sometimes you may buy a system, but people may see, oh, okay, this thing is not what we are used to do, right? And therefore, moving towards that may be challenging. And therefore, that's why we say that the people should transform first before we transform the system altogether, right? So then, of course, the next challenge is integration with shop floor, right? Some of the companies may not have devices to collect data from machines, right? So how do we connect that all together to create one seamless ecosystem? So these are some of the challenges that I have seen as I walk through many different industries. But of course, different industry will have their own requirements or challenges that they face on their own. So these are just some of the general ones that I can think of.
Okay, thank you, Dr. Chua. May I add that you were saying the challenges, some of them is due to cultural or more on the people skills, right? So what technical hiring do you think we need besides IT to implement MES? Which is the critical technical hiring that we need?
I think technical individuals in manufacturing factories are a key importance when it comes to scalability of what you intend to implement, right? So generally people with programming backgrounds, or some form of computer science, software engineering, mechatronics, those are good people or hiring people that you can bring in. But nowadays, technology advances so quickly, so fast. People talk about, developing citizen developers. So meaning to say that you don't need to know how to code, you just need to know how to put things together, right? And that's where I think systems are becoming easier to utilize. So you should have a technical part of it. But what I'm also saying is that the non-technical people need to be motivated to utilize technology and understand that it benefits them. Then the integration will be very, very seamless across the organization. So if people feel that, okay, this is a process which helps me to improve my productivity, then eventually that becomes a holistic kind of integration. Yeah.
Okay, thank you, Doctor. Okay, in the chat box, we have a question. This is towards Daniel from Mr. Tong, TriPlus. He's saying, mind sharing the average cost involved for the monitor system for plastic injection molding? Currently, we are using Exact, previously known as Macola.
Yeah, I recognize Hi, Mr. Tong. I recognize Triplas. I'm not sure if I met you, but I recognize the name. We charge by number of users, so it depends how big, how many people you have that gonna use the system. So roughly, if you have 100 employees, maybe like 20, 30 machines, depends of course what other secondary processes you have, but I think roughly if you're around 100 employees, you maybe need 15 users. Do you think so, Travis? You have nearly 40 users, I think. You are 300 people roughly.
Based on because we have economies of scale, so maybe our indirect is much smaller compared to the direct workers. So maybe you can say,
yeah, it depends.
yeah,
Exactly,
yeah.
it depends too how
Say-
many you have in the admin and.
Say to cover all your module, maybe 15.
15 users, yes, if you're 100 employees. Yeah, so if you need around 15 users, including implementation, I would guess somewhere 250,000 maybe. Depends a bit, but if you're not too big, I would guess around 200-300 if you're gonna be a very rough, but it's not millions. And
Daniel, Mr. Tong just added is
118 injection molding
40
with
he's
about
currently using
40
40
users. Maybe you call Mr. Callum from LH Plus because it's exactly the same size roughly, and he was also using Macola. So if you know Callum, maybe you call Callum. He will share, I guess.
Yeah, that will be the easiest to compare.
40 users. If you're up to that size, probably we are around 500,000, I guess. Now I'm very rough, but it depends a bit too, but around there, I guess.
All right, Mr. Tong, hope Daniel answered your question. So there's one question for Stephen from me. Can your scheduling system cater to other plastic industries, or is really built for injection molding?
The one I presented, Mr. Travis, is specifically for plastic injection molding. The
Okay.
rest I have to study, and then will be some customization. But the one I presented is specific for plastic injection molding.
Okay.
It's some interesting requests from some factory which they feel that they require this module. Of course, they are also working on some budgetary constraint. So I specifically developed for that and for plastic injection molding for at the moment.
All right.
Mr. Travis.
Okay. And can I add that I saw there's a setup time, but do you also consider set down, meaning to down the mold?
Yes.
Because
Yes.
both will take. Okay.
Well, due to time constraint, there are a lot of features that I am not able to put it on the slides.
All right. Thank you.
Yeah.
Travis, I got a comment and also I got a question following that. Give me about a minute.
Sure.
Daniel, thank you very much for being our platinum sponsor. We really appreciate the kind gesture, the support. Okay,
No problem.
Thank you. We'll be in touch sometime later. Yeah. Okay, I'm going to ask Dr. Chua to be a jury and a judge. You mentioned that the system that we want to adopt should be flexible, modular, and then scalable. Now, Daniel has given us a complete system. Mr. Liu, Stephen rather, has given us a partial system. For a little SME with like 10, 15, 20 machines, what would be the approach? I'm not going to ask Daniel or Stephen because it's not fair. I think let Dr. Chua maybe be the kind of jury on that. Would it be better to start with like a smaller system and then when you learn the ropes of it and then go into the complete ERP MES system?
Okay. Thanks, Mr. Eddie, for the question. I always like to encourage industries to take a more bite-sized approach. So whenever you start certain integrations, it's always important to start small but scale big, in a sense where you can apply smaller systems first, right? But the system that you invest on, it's very important to understand how you would eventually scale up, right? So whatever system that you decide on, eventually it needs to be able to be connected to other systems, meaning to say that there is that kind of flexibility. So usually I see systems with API connectors. I mean, these are a bit more technical, or database connectors that allow us to integrate with those systems. So that's what I meant by flexibility, right? So you can talk to different systems and it shouldn't have any restrictions, right? Then the next part of it is when you want to start, if you start by going with 100 machines at one go, sometimes it could be very overwhelming, right? Especially when you want to start certain process mapping, you want to really try out the system and make sure that it's really meant for you. So usually most of the industries we support, they start with one machine first, right? Once they gain a little bit more confidence, they know, okay, this is what I really want, it's customized to what I want, then move on to scale up further. So of course, different industries have different perspective of looking at it. Some want to go all in, right? To just invest and just get the systems all connected up and running. But some prefer that smaller bite-sized approach. Yeah, and when you start small, it actually is a very fruitful journey as you go through that journey of Industry 4.0, because you really know what you are working with, and eventually you know what to invest, and you are making the right dollar investment in your strategy. Yeah, this is how we see it. Yeah.
Okay, thank you, Dr. Chua.
Do I have the chance to comment, or?
Yeah, I think I was going to
Go
say,
ahead, go
Daniel,
ahead.
maybe you can defend your nebulous big system. Tell us, you know.
Yeah.
No, it's not about defending. Maybe I can just share how down here in Malaysia, we are still very immature, I would say, when it comes to usage of system, and especially SMEs, we don't know where to start, and we haven't used system before. Should we start small or big? And I think normally we think that ERP is something huge, very complex, dangerous to jump into a system. If we compare to Sweden, very mature market, and what we see there is that companies have went through this journey. We get a lot of new customers in Sweden that's changing or scrapping, that they are sitting and having maybe 5 different systems or 10 different systems. They have started with something and try to build it together, and in the end of the day, it's a monster that is so expensive to maintain, and some vendor maybe have disappeared. The vendor for your barcode scanning maybe is not there anymore. Very complex. And they are buying Monitor because there you have everything. So I would say that for small companies, just because you buy an ERP system doesn't mean you will use all functions in the ERP system in the beginning. It will take you years before you will use even half of it, maybe. If we look on Travis, he have used our system since 2013.
Mm-hmm.
There are a lot of functionality Travis is not using yet.
Yeah, I'm still surprised.
So
still learning new things.
I like you start bit by bit. You will not use a whole system in the beginning, but whatever system you buy, make sure you can scale. And I just want to say, if you start with some small, simple, customized system, later on you must integrate that with some other thing then. And then you must integrate that to something else. And then many people looking on this pyramid. So they start to build different things down there, and then they think they can put on an ERP on top. But if you put on the ERP on top there, that's gonna integrate with everything you have, we are on a very complex situation. So I think be careful. I think if you're quite small, that even if we can integrate, there are open APIs. Most systems have open APIs, but just because you have open APIs doesn't mean it's so simple just to start to integrate, because it is difficult. It is difficult even to run one single system for SMEs. So yeah, that is kind of our approach to it.
Yeah. I appreciate the comment, Daniel, but I think for many SMEs in Malaysia, cost is one big factor. If you're talking about, that system that you just mentioned that costs 250,000, straight away, 95% of the SMEs say, no, we can't afford that. So you've lost 95% of SMEs. But would that be
then we talk about the company with then we talk about quite decent company. If you're a small SMEs, you could easily buy for 50, 100,000, which will be much cheaper than customize or the work you need to do to integrate something. So
okay.
Yeah.
So perhaps maybe monitor can provide based on maybe user basis instead of implementation basis. So maybe it can help out the SME in Malaysia.
Yeah, that's what we do. It is based on user basis. So the smaller, the less training as well. The bigger, the more training, the more internal change management and so on. So for smaller, it's very, very affordable. Definitely.
When you say smaller, Daniel, is it you buy some modules first and then add on later on other modules, like it's scalable?
No,
modular?
We deliver everything in one shot. So you don't choose modules. But
just the number of people, number of users.
Yes. So what you choose to use basically is up to each customer. We start with simple if that's what they want.
Okay, got it.
And in that way, you also keep down the implementation cost, number of man days needed for training and so on.
Just to be fair, maybe I can ask Mr. Liu, Stephen, your system for, I don't know, 20 machines, any rough idea, how much it'll cost to buy your system?
Okay, Eddie, we are going on cloud. So to help the SME,
okay.
For 20 machines, we charge by subscription base.
Oh.
So the price range is around about 600 ringgit per month, in that range. And normally
per machine, you make 600 ringgit per machine per month.
600 for, you just say 20, yeah?
Yeah, 20 machines.
Yeah, based on 20 for 20 machines.
Oh, okay.
That price range.
Okay. Roughly lah.
Roughly.
Would that include training?
Will send my system engineer to do the site survey, so I can scale it flexible. There's some flexibility there, but for rough range is around there.
Okay, understand that. Got that.
Yeah, because this will also take away the investment of the hardware for the SME.
Yeah. Okay.
Right.
Thanks for that. Yeah.
Thank you.
Travis, I'm done.
Okay, thanks, Eddie. Yes, one question for T. In regards of the ergonomic design, would you advise sitting or standing? Which is the better position for machine tending?
Okay, yeah, it's not about sitting or standing. It's about even you are standing, you have to stand in a very ergonomic position. So it's not about standing. Actually, it's about movement. Actually, the best position is walking around, moving around. So that's why in Lean, when we design the workplace or standing, we actually implemented the certain criteria. Like, for example, you must have your footrest, your eye level must be, your whatever position must eye level, and then your width and so on, so that you don't strain your body. So it's very flexible. It depends on the process, but of course, comparing standing and sitting, standing is better, but it's not about standing. It's about movement. Even you stand, you are actually, your leg actually moving. Your leg actually moving, and then like you are walking. Okay.
All right. Okay. Because there's two school of thoughts here. So some say sitting is good, can go further. Some say standing is better because it's more attentive.
Indeed, actually, if you look at human ergonomy, we are designed to stand, not to sit, right? So, but standing itself is not good enough because if you don't move, you don't walk. It's not your blood is not circulate. You talk about ergonomy means you want your blood to circulate. Even if you're sitting on a very nice chair, massage chair where you can massage your blood to circulate, I think it's okay, right? But yeah, it's about getting your blood circulating, and then you're more attentive. Okay, and when you're attentive, you're more focused on your work.
All right, thank you, Mr. T. So, Sujata, do we have any more questions from the floor?
No more questions in the chat box. Yeah,
Okay, all right.
I think
So-
we can end today's webinar. But before everybody goes, I will just like to thank everyone once again. It's just not from, I think Mr. Eddie has, said his piece and thanked everyone and the speakers from on behalf of the committee members, but on behalf of everyone here, the participants, the MPMA Secretariat, thank you so much for taking the time to speak with us. And I just want to wish you all the best in your future endeavors. A very good presentation. Yes, time. There was a time limit, but nevertheless, we can always do more. Okay, so before we end today's session, can I ask to take a group photograph? Perhaps the secretariat who are in the webinar, could you switch on your videos so that we can take a nice group photograph for memory? Anyone going to switch on their video, or is everybody's so shy? Okay, everybody's giggling. Okay, thank you, Crystal. I can hear everybody giggle in the office. Okay, that's all? Okay, 1, 2, 3. Okay, another one and another one. Okay, thank you, T. Thank you, Travis, Stephen, Daniel,
Thank
Dr.
you.
Chua, and
Thank
Mr.
you.
Eddie Fong. Thank you so much. Thank you,
Thank you very
Crystal.
much. Thank you, everyone.
Okay, bye-bye.
See you
Have
next
a good
you.
time.
evening. Bye-bye.
Bye-bye. Thank you.
Bye.
Bye-bye.
Bye-bye.
Thank you all, MPMA.
Thank you, T.
Thank you.
Mhm.